All right, so last time we went through this factoring polynomials review, and I went through the exponents review, but I didn't record anything. I think I sent this document out to you, but I didn't send it to you with any kind of work. So what I want you to see on question number 1, now granted, you're going to see all of this in the video, right? So you can go back and take a look at it. On question number 1, what they're asking you to do is to factor out what we can factor out. Now, as a rule of thumb, we want to factor out anything that's going to leave inside of parentheses a positive variable. All right? So that's why I don't take out a positive 8. Because if I took out a positive 8, in order to get the negative 8s squared minus 40s, I would wind up with a negative s inside that parentheses. I don't want a negative s inside the parentheses. All right? So I want to take out a negative 8. I want to have a negative being factored out so that I have a positive variable left in. Does that make sense? Right? Now, the nice thing about factoring is, can I check my work? How do I check my work? By distributing back in. Exactly. So at the end of this, right, and that's where you see my lines here, if I factor this back in or distribute it back in, negative 8 times s, or negative 8s times s is going to be my negative 8s squared, and negative 8 times positive 5 is negative 40. And I've got an s there, so negative 40s. So that's going to be factored out. I think probably a lot of us did pretty well with this question last time, correct? Okay? Over here on number 2 can be kind of tricky because I have a c in both, so I factor out the c. And a lot of times people forget, that I do want to test this to see if I'm going to get c squared minus c back. So I'm going to distribute the c. C is c squared. C times negative 1 is what? Negative c. All right, so I need to be able to get back to my question to make sure that my answer is correct. Okay? Do we understand why we have a negative 1 left there? All right, because essentially what this is a variable with nothing in front of it. I have a what always? A 1, right? So as I factor out that c, I'm left with the negative 1 that had been there, okay? We feel pretty good about that? How many felt like you probably got that one right on the quiz last time? Okay, good. All right. Number 3, right? We ought to see this as a sum difference, and this is actually works out as a really good question for us to see because is this very similar to what we saw yesterday in class? Absolutely. So what I'm looking at there is I can square root the n and I can square root the 36, right? The square root of n squared is n, so I'm going to put that in both places. The square root of 36 is 6, so I put that in both places. Because it's a negative, I'm going to make it a sum difference. So I'm going to get n plus 6, n minus 6. How many of us feel pretty good about seeing that type of question? Okay? All right, good. All right, let's take a look at our next page. All right, our 4 and our 5. All right, so on 4, what this is going to come down is factoring by grouping, right? Do we remember how to factor by grouping? Hopefully we do. So I'm going to look at the x cubed plus 6x squared. I'm going to take out what I can take out, which in this case is x squared, leaving me with x plus 6. And again, I can check that. Does x squared times x equal x cubed? And does x squared times 6 equal 6x squared? Well, yes, it does. All right, so that works. Now, if factoring by grouping works, I should always get the same thing inside the parentheses in both sets, right? So I factor out, again, a negative 9, not just 9, okay? I factor out a negative 9 so that I get a positive x. I don't want a negative x left inside there. So as I factor out a negative 9, I'm going to check that again. Negative 9 times x is negative 9x. Negative 9 times 6 is negative 54. All right, so does that work? Yes. All right, so hopefully we understand that whenever I get the same thing in both those sets of parentheses, that they come down as a single set. All right, and then I'm going to take these two pieces right here and bring them down together. So I'm getting x squared minus 9 times x plus 6. All right, now where a lot of people will stop is just right there with what you see in that step. But from yesterday's lesson, what do we know? We know that we can do what with x squared minus 9? Right, because 9 is a perfect square. So what's the square root of x squared? X and x. What's the square root of 9? 3. So I'm going to use it as a sum difference. And because this was x cubed, how many roots should I get? I should get 3. If I had left it like this, I should have known I was wrong because I left it with only 2 roots. Okay? That makes sense? Now, if they were asking me, what are the roots of this? We would say -3, 3, and -6, correct? But it's just going to ask for the factors. Because we're just asking for the factors, those are those 3 guys right there. All right, how many of us felt pretty good about that particular question on the quiz? Felt pretty good? Do we think it was maybe the last one that got us? Maybe, maybe not. All right. X squared minus 3x plus 2, that's just a matter of factoring down, noticing that it's minus plus, so I should get minus minus, right? Because negative times negative is a positive. If I add 2 negatives together, I get a negative. The nice thing about a question like that is that 2 is a prime number, so the only numbers I can use are 2 and 1, right? And because it's negative negative, it doesn't matter which order I put them in. A while back, though, I gave you a list of instructions whenever we look at matters like this, where we had, let's say ax squared plus bx plus c. Then we knew it was going to be plus plus, right? Right? What if it was, in terms of up here, it was, here we see minus plus, so we know we're going to get minus minus, correct? Right? And so how many of you remember those notes? So I need to go through all of them again? Anybody need to see those list of instructions again? All right, nobody in this class anyway. Okay. All right, so those are the 5 factoring questions. All right? And for the most part, everybody did pretty well. Janet, I gave everybody their numbers from their quizzes, but because this is being recorded, I won't say those out loud because I don't think I was recording whenever I gave everybody else's. Okay. So the next thing we want to look at, and the hardest thing here, is our exponents. Okay. Really, really struggle with exponents. Right. This is the hard stuff. All right. Do we remember seeing questions like this? Yeah. All right. So I'm going to kind of start with just this one. I've got 1 over 4 to the negative 2. So whenever I have a 1 over a number with a negative exponent, how do I get rid of a negative exponent? By moving that set, in this case, 4 to the negative 2, above the division line, right? So, that would be 1 times, right? Because I've already got a 1 up there, but is that 1 going to change anything? No. So what I'm going to be left with is 4 squared because that exponent's going to change signs. What is 4 squared? 16, right? So we probably saw one like that, and so hopefully everybody got that one correct, right? All right. Let's come over here to this one. I'm just going to wipe this out. You'll be able to see it in there, but just so we're working it out again. All right. So you're going to see it. It's going to look like this. All right. It's going to look very, very similar to that. All right. Just like when we were talking about variables with no coefficient in front of it, we knew that all variables with no coefficient have a coefficient of 1, correct? What do all variables have as an exponent if an exponent is not known? What's the exponent? 1. So that's why what you saw up here before I erased it is that I had a 1 with that b and a 1 with that a because there was no exponent there. Now, another thing I want to address is if I have variables all multiplied by each other, what do I do with their exponents? Do I multiply their exponents or add their exponents? Add their exponents. But can I add exponents of unlike terms? No. All right? So I need to get like terms together. And because this is all multiplication, can I move all the terms around? Yeah, so I can move all the a's together, and I can rewrite this as a cubed, a to the negative 4th, a to the 6th, a to the 1st. Right? And I can write that as b to the 1st, b to the negative 3rd, and that's it. Right? There's only 2 b's. All right, now I'm just going through and I'm adding all the exponents up of a, right? What's 3 plus negative 4? Negative 1, right? What's negative 1 plus 5, or sorry, negative 1 plus 6? 5. What's 5 plus 1? 6. So I'm going to get 8 to the 6th, right? What's 1 plus negative 3? B to the negative 2. Now, I'm going to tell you that I'm going to make a personal rule, so hopefully this will clear things up on the quiz, is that when we see something like this, the form I want to see it in, and I'm going to do away with all other options that will be confusing, is that I want positive exponents. All right, so I would put that b to the negative 2 below the division bar so that I got a to the 6th over b squared. Does that make sense? Right, so what I'm going to do is if you see something like this, I'm going to go ahead and throw that option out so that, because both of them are technically correct. All right, reduce it to just one correct answer. Will that help you out? Okay, I'm hoping it will, and it really shouldn't change the results. Okay? All right. So for some of you, some of you feel like you probably went with this first option over here? Yeah. Okay. And that's particularly confusing because I think in one of these next questions we see essentially the same thing, right? We see this a to the 24th, b to the negative 4th, and this answer over here. So we think, well, I don't really know which option to go with. So I'm going to erase this one as well. This one is probably the most likely to be missed just because it includes the most steps. Okay? But any of these questions can be done if we take it one step at a time. All right, so my recommendation to you is this, is ignore the denominator, focus on the numerator first. Okay, now you have it's a 10 question quiz, right? Right, if you have to, do the first 5 on one side of that box sheet, do the other 5 on the other side of the box sheet, right? So that you can take up as much space as you need to. You don't feel like you have to cram things in, right? Because ultimately, am I really worried about the box sheets? No, not really. So I'm going to rewrite this as a to the negative 4th squared, b to the negative 3rd to negative 4th. Okay, we're just going to focus on that. Okay, so we said that when we have variables times variables, that we add their exponents, right? So what do I do whenever I have a variable with an exponent to an exponent? What do I do with those exponents? Multiply them, okay? So let's go ahead and do that from left to right, right? Do I need to do anything here with a? No, okay? But have an exponent there? It's what? 1? Okay? Now, a to the negative 4th to the 2nd. What does that become? A to, that's confusing. A to the negative 8. Now, what does this mean when I have a to the 1st, parentheses, a to the negative 8th? What am I doing with those things? No, what is actually happening between those two variables? Multiplying. So here's what I'm going to do to even simplify that a little bit further. I'm going to drop the parentheses all together and just write this as a to the 1st times a to the negative 8th, right? That way you don't end up thinking, okay, I have to multiply exponents if one is inside of parentheses and one is outside of parentheses, right? That can be confusing. All right, so I'm just going to write it as this. Now, this b, is it just multiplying by that? Right, so could I just write b to the 1st there? Sure. All right. Is the exponent to a inside my parentheses? 1. So it says a to the 1st times b to the negative 3rd, all to the negative 4th, right? So it's all just multiplication. We just have all multiplication in here. So it's not a totally crazy different thing. So a to the 1st becomes what? A to the negative 4th, and b to the negative 3rd becomes what? B to the 12th. Now, does this look similar to the question we saw previously? What did we do at this point with that question? Okay, we rearranged things so that in this case we'd have a to the 1st, a to the negative 8th, a to the negative 4th, b to the 1st, b to the 12th, right? All right, now, what do I want to do with those exponents? Add them. What's 1 plus negative 8? Negative 7. What's negative 7 plus negative 4? Negative 11. All right. What do I do with the 1 and the 12? Add them and I get 13. All right. Am I done right now with my numerator? Yes, this is the numerator. That is the solution to the numerator. I'm not done yet, though, right? All right, but can we do this if I take it one step at a time? Okay, now, let's take our denominator. Okay. Let's see. Let's kind of take care of this as we go. A to the third to the fourth becomes what? A to the 12th. Okay? And that's just b to the negative fourth, right? Do I need to do anything to it? No. What's a to the third to the fourth? A to the 12th. All right? Can I rewrite this as a to the 12th, a to the 12th, b to the negative fourth? Okay? What's a to the 12th times a to the 12th? A to the 24th, b to the negative fourth. Okay? That is my denominator, correct? All right, so what I'm going to do now is I'm going to take my numerator and put it in the numerator. So I have a to the negative 11th, b to the 13th, over a to the 24th, b to the negative fourth. Now, I want my answer. Does my answer have to all be in the numerator, or do I just want my answer to have all positive exponents? All positive exponents. Okay, so do I want to bring this a to the 24th up, or do I want to bring a to the negative 11th down? A to the negative 11th down. All right, so that's going to be a to the negative 11, or sorry, what does it become as it comes down here? It becomes positive 11. So a to the positive 11. Do I need to do anything with a to the 24th? No, so it's just times a to the 24th. B to the 13th, am I going to move that down or leave it where it's at? Leave it where it's at. All right, so I got b to the 13th. What about that b to the 4th? Is it going to stay there, or is it going to move up? Move up. So what does it become as I move it up? B to the 4th. Now, one final step, right? What do I do with those exponents? Add them. What's 13 plus 4? Okay, b to the 17th. What's 11 plus 24? 35. A to the 35th. I have all positive exponents. That's the way. Can we do that? All right, so look at it as one step numerator, second step denominator. Set them over each other, decide what needs to move where, then simplify. Okay, can we get that question right? Great. Okay. All right, let's go to another one. Scientific notation. So how many of you feel like you probably missed this one? All right. All right, and I probably didn't do a great job of explaining how to get there. All right, so we have 0.0004 times 10 to the negative fifth. All right, and then we have 5,000. We could go through a bunch of stuff here, but I want to show you how can we make sure that our answer is correct. All right, everybody tomorrow should have a calculator, right? Yes? All right, so let's do it this way. 0.0004, am I right there? Times 10 to the, and I'm going to use parentheses because it's an older calculator, negative fifth, okay, and I'm going to close up both sets of parentheses. Does that make sense? Everybody with me there? And I'm going to multiply that, so I'm going to use a different set of parentheses, times 5,000. Right, and I'm going to hit enter. Notice that my calculator is going to give me my answer in scientific notation, and that answer is this. It is 2 times 10 to the negative fifth. That's what E means. 2e to the negative fifth means 2 times 10 to the negative fifth, and that's already in scientific notation, correct? Perfect. All right, so you might want to try that and make sure that you can get 2e to the negative fifth out of that. Okay? All right. Now, the next thing I would do is let's go ahead and do the denominator. All right, I'm going to pull this guy up, clear this guy out. Okay, parentheses, 0.007 times 10 to the, I'm going to use double parentheses, 16 close both sets of parentheses, close the one around the 16 and close the one about the whole thing, times 3,000 times 10 to the 5th. Close that parentheses. Okay? That's giving me 2.1 times 10 to the what? 22nd? Okay. All right. So from here, we should be able to do some of this kind of on our own at this point, right? What's 2 divided by 2.1? Somebody tell me? 0.95 times 10. All right. Let's see. If I would end up adding that down, so wouldn't that be times 10 to the 27th? Right? This isn't scientific. So this would need to move that way. So I would need 9.5 times 10 to the what? 26. Now let's check our answer, right? Because I want us to be able to check it and get it right. This is how I'm going to check this. I'm going to write parentheses 2 times 10 to the parentheses negative 5th, close both sets of parentheses. Now I'm going to hit divide by parentheses 2.1 times 10 to the 22nd, close parentheses. 9.5 times 10 to the negative 28th. Notice that we went the wrong direction, right? Instead of adding, subtracted 1, right? Do we see the importance of checking our work? Because in the answer list, they'll probably give you options that are close, but they're built around 27, either adding or subtracting 1. Okay? So we should be able to use this to get the right answer. If nothing else, we can solve this using our calculators, correct? All right. Do we feel a little bit more comfortable on how to use a calculator to get there? Take it one step at a time. Get your numerator, get your denominator, divide your numerator by your denominator. The calculator should be able to give you quite a bit of that. Okay. Boy, that looks complicated, right? Was this our last one? Let's double check. Yep, it's the last one. All right, let's erase this and start over. Maybe. Try to erase it. All right, we got most of it. All right, again, this is hearkening back to some of those earlier questions, right? But it's more complex because we see different kind of variable parts to this. But look at our A. It has an exponent, right? It has an exponent that's being taken to an exponent. So this is that power rule. What do I do with exponents whenever I have an exponent to an exponent? Multiply. So what we're saying is, what is y times x minus 1? What do I do with the y? Distribute. So y times x is yx or xy. What's y times negative 1? Negative y. So does that make sense? Okay. Now keep in mind that that's just multiplication, so the variable there with a is 1, correct? So that is going to be a to the what? What's 1 times negative y? Negative y. Okay. And I've got b to the negative x to the negative y. So what do I do with negative x and negative y? All right, what's negative x times negative y? xy, because the negatives cancel out, so I've got xy. Now, before I move on, let's simplify our numerator. All right, now I've got two a's. Are a's like terms? All right, what do I do with variables that are alike, that have exponents? What do I do with those exponents? Add them together. So what we're saying here is, what is xy minus y plus negative, or just xy? What's x? No, I can't subtract y from xy, right? Can I subtract y from negative y? Right, well that's negative 1y and negative 1y, correct? So what is that? xy minus 2y, right? Now that's my exponent, so what I'm saying here in my numerator is that I have a to the xy minus 2y, and b's all alone, right? It's just b to the xy. All right, now down here I have b to the negative 1. What do I want? Do I want this, or do I want all positive exponents? All positive exponents as much as I can get it. So what do I want to do with that b to the negative 1? Bring it up. What happens to that negative 1 as I move it up? All right, so I'm left with a to the xy minus 2y. Is that going to change? No, because there's no other a's, right? But then I have b xy times b to the first. Well, what do I do with those exponents? Add them. So I still have a to the xy minus 2y. Now I have b to the what? What's xy plus 1? Xy plus 1, because there's no like terms to combine. It just comes together as a single form. And all that's over 1. That's my answer. Do we feel like we could probably do that one this time around? Right? Does that look a little easier than what I had on the board previous? Maybe, hopefully. All right. So, I think we're out of here at what, 10:36? So when we chewed up that time, what are you going to come in tomorrow? You're going to come in and you're going to ace that SLO, right? Okay, so I'm going to hit stop right here. What should you do tonight? Study, right? And let's knock this thing in the head and celebrate. I want to, if I get my entire Algebra 2 group, because it's got to be not just your class, but the other class too, if we get 80% of us hit 8, 9, or 10, right, I want to celebrate. So I'm going to bring in some candy or something, right? Maybe even homework passes for everybody. I don't know. I'll think of something, all right? Or maybe you guys think of something reasonable, and we'll do that.